Hello, here's Miss Wesley, or I'm Miss Wesley, I should say, and this is the last skill for Unit 7. So hopefully some of you are tuning into this one because it is something to know, even though you might be able to figure it out on your own. But we're going to focus on right now is the perimeter and area. So last video we talked about the perimeter. We're also going to focus on area right now of figures on a grid. So if you think back to the last video, we didn't have to graph those shapes, but in this scenario, you might be given figures, polygons, quadrilaterals, whatever they might be, on an actual grid. So we're going to talk about how do you find the area and perimeter of irregular shapes, because these shapes we're going to look at today are not all going to have the same side lengths like they did in the last video. So take a minute to copy down your essential question, and then we're going to start with some radical rules. So what we did last time is we recalled how to simplify radicals, but you also need to know what some basic radical rules are for combining them. Alright, so if we look at this first one, it says 2 radical 3 plus 4 radical 3. A radical rule you want to keep in mind is that you can combine radicals if they have the same number under the radicand. So for instance here we have radical 3, those are the same, so we can combine them, and all you combine is the coefficient out front. So you can also think of it like x's. If this was to have read 2x plus 4x, you would say, well, I have 6 x's. Well, here I actually have 6 radical 3's. I had 2 from the first one and 2 from the first one and 4 from the second term. So this would be our final answer. If we use that same logic with the second example here, I notice that I have 5 radical 5's here and I have 3 radical 5's there. So those two can combine to give me 8 radical 5. But then also take a look and say we have these constants that are just floating in here, this 5 plus the 4, those can get combined because those are constant terms. They don't have any variables or radicals attached to them, so they also go together. So that would mean I have 9 plus 8 radical 5. So that is our final answer there. Now if you were to have written that 8 radical 5, that was supposed to be a radical sign, plus 9, that's also fine. There's nothing wrong with that. But just know that you can't combine the 9 with the 8 radical 5 in any way. All right, last one we have here. So I look and I say, okay, I have 2 radical 5's plus 3 radical 5's. Those can get combined together because, again, they have the same number under the radical. So I have 5 of them. So I have 5 radical 5's. Plus, I have this 3 radical 6 hanging out here. There's no other term with a radical 6, so there's nothing I can do with that except to bring it along. So this would be my final answer. Now again, if you were to reverse that and have written 3 radical 6 plus 5 radical 5, totally fine, nothing wrong with that. So that is a skill that you do need to know when we focus on specifically these perimeter problems, because if you think about how we find distance, we use Pythagorean theorem, a squared plus b squared equals c squared. We always tend to end up with a radical, so it's important that you know how to simplify your final answer. So let's scroll down here and look at the first example. Okay. So this example says, find the perimeter, so that's our goal, of a triangle that has vertices A, B, and C in simplest radical form. So what I'm going to do is I'm first going to graph each of those coordinates so I can actually see what kind of triangle I am dealing with. So -5, -1, so it'll be about here. A little tricky to do this on the iPad. I have 0, 4, so remember that means I'm not going left or right anywhere, I'm just going up 4. So that would be here. And then I have -2, -4. Alright, so I'm going to label those. That was an A, this was my B, this was C. So it would look something like this. There we go. Not too bad if I do say so myself. Alright, so now that we got that out of the way, we need to find the perimeter of this triangle. So meaning we need to find the length of each of these sides and then add them together. So we have a couple options here. We know we have to find the length, so meaning that we're going to have to use Pythagorean theorem. And thinking Pythagorean theorem, thinking about how we find length, we always do that by making our chart. So I'm going to start with that. I'm going to start off to the side here and make my change in x. I'm going to make my change in y. I'm going to make my a squared plus b squared equals c squared. Now, this is going to be a little bit of a bigger chart because I have 3 side lengths I'm trying to find. So I'm going to make a row for my first side, AB. I'm going to make a row for my second side, which I'll let be BC. And then I have a third side, AC. So all I did so far was I set up my chart. I didn't put slope on there because perimeter has nothing to do with slope. So if you put it on your chart, there's nothing wrong with it, but I'm just going to save the space and the time here by not finding it. So now I have to find the changes in the x's, the changes in the y's for each of my 3 sides. And yes, I could go back and, where's my magnifying glass? Sorry. I could find the distance using the coordinates like we know how to do for each of these spaces. But what you can also do is what's called the boxing method. So I'm actually going to go with that because it's actually, I just said actually a bunch of times. It's really straightforward if you have the graph. So what I'm going to do to box this in is from A to B, I'm going to draw in, I should make that a little bit bigger. Hold on. All right, I'm going to draw in from A to B, so I have a box. So I have a right angle. I just walked up as far as I had to, and I walked over as far as I had to get to B. Now what I'm going to do is I'm going to count how many spaces I had to walk up, and then I'm going to count how many spaces I had to walk over. So from A to B, I had to walk up 1, 2, 3, 4, 5. So I'm going to put a 5 by that. And I had to walk over 1, 2, 3, 4, 5. What do you know? So those are my changes in x's and changes in y's for A to B. So if I do Pythagorean theorem on that, I'm going to get 5 squared plus 5 squared equals c squared. 5 squared is going to give me 25 plus 25 equals c squared. I don't have a ton of room. So plain and simple this is I'm going to end up with c equals, and this would say the square root of 50. All right? So one side, done. Well, now I got to do the same exact thing for my other sides. So I'm going to box in from B to C. So I'm going to walk straight down from B, and I'm going to stop when I have to walk over to get to C. So I have to walk over 2, so that's going to be my change in x. And then up and down, I have 1, 2, 3, 4, 5, 6, 7, 8. I'm going to put an 8 there. And again, that's vertical, so that's going to be my change in y. So you know what to do, Pythagorean theorem. 2 squared plus 8 squared equals c squared. 2 squared is going to be 4. 8 squared is going to give me 64. So when I'm all said and done, c equals square roots. 4 plus 64 is going to give me 68. All right, we have the length of 2 sides. We need the length of our third side. So I'm going to box in from A to C. So I'm going to walk down, and I'm going to walk over. If I count, over is 3, so that's my change in x. Up and down is also 3, so that's going to go here. One more time, 3 squared plus 3 squared equals c squared. I get 9 plus 9. So this one's going to leave me with c equals square root of 18. All right, so that might have been a lot, but again, if you look back at what I was doing, I was simply boxing in between each of the vertices, or the corners of my shape, and I just counted how many spaces I had to walk in each of them, and put those, that dot shouldn't have happened, sorry, put those in the corresponding places, and then we did Pythagorean theorem 3 times. So the last thing we actually have to do is we have to go back and find our perimeter. So we know the perimeter is, I need that to go away. Perimeter is equal to the length of 3 sides, so it would be AB plus BC plus AC. Where's my A? Come on. There we go. All right, so we know that AB came out to be square root of 50. We know BC came out to be the square root of 18. And we know AC came out to be the square root of, oh, I messed up. That was a 68. For BC. Sorry, talked too fast. All right, this one was 68, and this one was 18. All right, there we go. So that's our perimeter, and those don't have like radicals, so I can't combine them. However, this set in simplest radical form. So meaning what we have to do is we have to go back and check each of these to see if they can be simplified at all. Meaning we have to think back to our perfect square list that we used last time. So 1, 4, 9, 16, 25. Hopefully you guys are knowing where I'm getting these numbers from and you're comfortable writing this list yourself. What's that, 7? I always get stuck here. 64, 81, and 100. Okay, so I'm going to start with 50. I'm going to ask myself, okay, which of these numbers on the list can divide into 50 nicely? And again, I'm looking for the biggest number. And 25 comes to mind right away. So I'm going to break 50 down into the square root of 25. And I know 25 times 2 will get me back to 50. But I also know the square root of 25, so meaning this is going to turn into 5 radical 2. So that was my first one. I'm actually going to draw like a dotted wall so we don't get these mixed up. All right, 68. This one might not come to mind as quickly. So in your calculator, take 68 and divide it by maybe, I don't know, 16. See if that works. It's not. If you divide it by 9, it's not. But 4 is actually going to work. So I'm going to break this up into square root of 4. And my calculator tells me that 4 times 17 will get me to 68. But again, the square root of 4 I know is 2, so I'm going to take that out. I'm going to leave on the inside the square root of 17 because I do not know the square root of that. All right, one last one. So think right now for me, think hard. Which number in this list can divide by, or can be divided into 18? Now 18 is a pretty small number. So is it 9, is it 4, is it 1? Hopefully you're thinking 9. 9 can go into 18 2 times. And again, the square root of 9 I know is 3. So I bring that out and I leave the radical 2 alone. So now if I go back, this is still what I started with. It's still the exact same line I had here. I just simplified each of them. So now I'm looking and I'm noticing that, hey, I have a radical 2 here. I have another radical 2 here. So I can actually combine those to write out my final answer. So my final answer for this problem, the perimeter, is going to be, I have 5 radical 2's plus 3 more radical 2's. So I actually have 8 radical 2's. So 8 radical 2 plus, notice I have this other term here, this 2 radical 17. There's nothing else that has a radical 17, so that just has to get brought along. 2 radical 17. And that is our final answer. So yes, it took us a few minutes here, but the process is not necessarily a hard process, it's just a long process. We had to do Pythagorean theorem 3 times, we had to simplify each of the radicals, and then we did have to combine to get our final answer. So I am going to try one more on the next page to see if it helps you to understand the process and let it sink into your brain, and then we're going to take a look at some area questions. So flip over to the next page once you have everything here, and I will meet you there. Alrighty, so for this problem, it also says to find the perimeter of the polygon graph below in simplest radical form. So just like we did before, I'm going to start with the box method, but notice that this shape does not have letters on the vertices. I'm just going to go ahead and add those in. Doesn't matter where you start. If you want to be consistent with me and have your letters match, I would recommend starting where I did and using the same letters. You could have started like X, Y, Z, and then you'd have to go backwards. Or like J, K, L, M, N, whatever you wanted, whatever your heart desires. So now that I have this here, I think back to what we did in the last problem, and I know I'm going to have to box in this shape essentially. So like for my first one, I'm going to have to box in from A to B. I'm going to jot down 3 by 3. I'm going to move over to my next piece. B to C. What do I have that time? 1, 2, 4. And I have a wonderful 1. Keep going. Let's go to purple. From C to D. So I have a 1. There's my 1. And then 1, 2, 3, 4. So another 1 and 4. Orange, D to E, I see a 2 and a 2, and then our last one. There we go. 4, 6. All right, so all I did so far was I simply counted up spaces and jotted some numbers down. So next I'm going to make my chart. Where do I want to make my chart to help me out? I'm going to go down here. So I got change in X, change in Y, a squared plus b squared equals c squared. And then I'm actually going to scroll down in a second because I'm going to have a lot of rows. I'm going to have, let's count up how many sides we have. 1, 2, 3, 4, 5. So I need to make 5 rows for this. So I'm going to pause the video just to get that set up, but take a second to make those rows for me. Okay, so my table is finished. I have change x, change y, and again I have Pythagorean theorem because I'm only focused on the length since we're dealing with perimeter, and then I wrote down my 5 sides, A, B, B, C, C, D, D, E, and then A, E. So what I'm going to do now, hold on. All right, let's try that again. There we go. All right, so what I'm going to do now is I am simply going to take my numbers. So for instance, I'm going to take this 3 and this 3, plug them into the table where they should go, and then I'm going to work on finding the distance for each of the sides. So since we have the numbers there, and I know you guys know how to use Pythagorean theorem, I'm going to pause the video, get my table filled in just to save a little bit of time here, I guess. And why don't you do the same for me? Because when we're all said and done, I'm not going to do any simplifying. I'm just going to fill in the table. So why don't you pause the video, try that on your own, and then when you're ready, press play, and my answers will all show up for you. All right, so let's try that. Did you do your table? I hope you did. And this is what our table should look like. So if we kind of take a second to summarize all the side lengths that I found. First side length was radical 18. Then I had a radical 17, another 17. DE gave me a radical 8. And then if we scroll down, ignore those floating 3s, they won't stay for me, sorry about that. All right, we have a radical 52. So those are each of my side lengths. So the last thing we have to do is we have to add them up to get our final perimeter. All right, so I'm gonna scroll down a little bit more. Again, ignore those floating 3s, they're really making me mad. Well, actually, probably can do this, watch. Oh, that's gonna take forever. I was gonna draw over them. There we go. And then I'll just write them in up above. Make my pen smaller. 3, 3. What do you know? All right. So back to where we were. So we know the perimeter right now is, I'm going to take each of those side lengths and just write it out. Radical 18 plus radical 17 plus radical 17 plus radical 8 plus radical 32. So the question did say in simplest radical form, so we have to break down as many of these radicals as we can. So what I'm going to do next, there's those darn 3s again, hold on. All right, now they're gone. So I'm going to take a minute and off to the side, I'm just going to write out our perfect squares so we don't forget them. So 1, 4, 9, 16, 25, let's hope I don't get stuck this time. 36, oh, I jinxed myself. That's 6, 7s are 49s. 64, 81, and 100. All right, so looking at this list, 18, we did this one in the last example. So hopefully remember that 9 can go into 18. 9 goes into 18 2 times. The square root of 9, though, is 3. I'm going to leave the radical 2. All right, if we move to our next one, 17. If you think about this list, 9 can't divide into 17. 4 can't divide into 17. Yes, 1 could divide in, but I'm going to be left with exactly what I have. And this is a special case because 17 is a prime number, so nothing can divide into 17 except itself and 1. So these 2 radical 17s we're actually going to leave. We can't simplify them. If I move over to the 8, though, 8 can definitely be broken down. 4 can go into 8 2 times, and square root of 4 is 2. And same with 32. If you look at my list, there's a couple numbers that can divide into 32, but remember, I'm looking for the largest number. So yes, 4 can divide in, but 16 can also, and that's larger than 4, because 16 times 2 will get me to 32, and I know the square root of 16 is, I'm blinking, 4, sorry. All right, so now we have 1, 2, 3, 4, 5 radicals. They're all in simplest terms, so our last step here is to write them combining whatever like terms we have. So if I go back, I'm going to notice that, remember, I had 2 of these radical 17s. So I'm going to put those right together and say, okay, I have 2 radical 17s plus, now if you look, notice that these all have radical 2s. So if I add up just my coefficients, I have 3 plus 2, which gives me 5. Plus 4 more gives me 9. So we actually have 9 radical 2's. And that is our final answer. So, all that work, but again, it's the same process over and over each time. Box in each of your points between one another, find all of their lengths using Pythagorean theorem, write it out, simplify what you can, and then combine them with, again, only like terms to give you your final answer. So hopefully the process of perimeter isn't too bad. You could do this for any shape. So you'll just box in as many times as you need to, depending on how many sides there are for that shape. We have 2 more examples on the last page. I know this is a long video, but the last 2 are focused on area. So if you flip over to example 3, I will meet you there so we can kind of take a look at this from a different perspective. Okay, example 3, you'll notice again, we copied and pasted it from an exam. I believe it was last year's exam. It says triangle RST is graphed on the set of axes below. How many square units are in the area of RST? So we talked about how perimeter is the sum of all the side lengths. Area is the amount of space that's inside this 2-dimensional shape. So meaning we want to know how much space is in our shape here. All right, now I'm going to erase that just so it doesn't get confusing, but that is what we're looking for. So we're going to start the process just like what we did before. I'm going to start by boxing in each of these pieces here. So from R to S, so what do I have here? 1, 2, 3, 4, 5, 6. And then I have 1, 2, 3. I'm going to go over from R to T. Did I go far enough? Yep. So 9. Again, please check my math. 12. We got one more. 6. And another 12. All right, so what we want to do is we want to find, like I said, the area of this space in here. So what we can think about is that the area of what I have would essentially be the area of this entire square, take away the area of each of these triangles. So what I'm going to start by doing, step 1, is I'm going to find the area of the square. Okay, and if I look at the square, those 2 sides together would give me 12. These 2 sides together would give me 12. And I already know that this side over here is 12, this side over here is 12. So the area of a square, ooh, that's my pointer still. Area of a square, any like rectangle, parallelogram is always length times width. So our square is 12 by 12, which gives us an area of 144. So what that means is the area inside, I don't want to go over it with my colors, but the area of this entire shape here, if I was to shade it in, is 144 square units. But we know that's not actually what we're looking for. So the next thing I'm going to do is I'm going to find the area of each outside triangle. So what that would mean is I'm going to find the area of my purple triangle, I'm going to find the area of my orange triangle, I'm going to find the area of my green triangle, because if I can find those 3 areas, I can then subtract them away from our total area of 144 to get our final answer for what must be left over in the middle. So first thing you want to know is area of a triangle formula. This is given to you on your reference sheet, so you don't have to worry about memorizing it. But the area of a triangle is 1/2 base times height. So we're going to use that formula 3 times because we have 3 outside triangles. So for my purple one, the base was 3, the height was 6, so 1/2 times 3 times 6. that is going to give me, and you can always check this in the calculator, it's going to give me 9. Moving on to my orange triangle. So 1/2, the dimensions of that triangle were 9 by 12. So type in your calculator, you are going to get 54. And my green triangle. 1/2, what do we got this time? 6 times 12. That's going to give us 36. Okay. So, step 1, we found the area of the entire square. Step 2, we found the area of each of these little triangles. So my third step, now to save room, I'm going to go way over here to the left. Step 3 is we're going to subtract the area of the triangles away from the area of the square. So what I'm going to do is I'm going to start with 144, because that was our total area. And we are going to subtract away from that the 3 areas of the triangle that we found. So I'm going to subtract away 9, I'm going to subtract away 54, and I'm going to subtract away 36. So if you type in your calculator 144 minus 9 minus 54 minus the 36, that is going to leave us with a final area of 45. And that is in fact our answer, which matches with what we have here. So again, both of these formulas that I got here, area of a square, any parallelogram, and then area of a triangle, those are both on your reference sheet, so you do not have to worry about memorizing them. But you can use this same process like what I just did here, finding the area of the outside shape, subtracting away the outer pieces then for any shape in any kind of triangle. So it might not always be a square like how we had 12 by 12. You might be in a situation where you have 12 by 15, and that's fine. You would just use the same process. So if this comes up, this would be the strategy that you do want to take, and I'm going to take a look at one more example here, for example 4, and then this video is over. Okie dokie. Last example, example 4, and then unit 7 is over. So coordinates of vertices A and B of triangle ABC are 3, 4, and 3, 12. If the area of ABC is 24 square units, what are the coordinates of point C? Alright, so now what I'm going to do is I'm going to draw in a set of axes here because I don't have one. If you do, then you're one step ahead of me. I'm going to let my graph, oh, that line's not too straight, like something like that. Let's plot the points. A is at 3, 4, and B is at, let's say, 3, 12. So I'm just going to keep going. Oh, look at that, I got very close. Oh, that's a really big circle. Alright, that's B. So I'm going to connect these. Okay. So we know the area of our triangle is 24 square units. So if we think back, we know that the area of a triangle formula says 1/2 base times height equals the area. Another way to write that is base times height divided by 2. So looking at A to B here, this could be considered the height of our triangle because it's going straight up and down. So I'm going to put a little, let's see, what's the height of that? 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to put an 8 there because I know that's my height. And I know my area was 24. So if I go back to this formula for a second, I'm going to plug in what I know. So I know the area is 24. I don't know my base. I'm going to try and find that out. But I do know the height is 8. That's not a 6, by the way. That looks like a 6 right now. That's a B. Hey, that looks better. All over 2. Alright, so if my goal is to find the length of the base here, I'm going to cross multiply. So 24 times 2 is going to give me 48 equals 8B. Hey, what's going on? There we go. So if I want to find the length of B, I'm going to divide both sides by 8. So I end up with my base length has to be 48 divided by 8 is 6. So what that means is I need to find where C could actually end up at. And we have a couple different choices. if you're thinking about how triangles could look, there's a lot of different ways to draw a triangle. So for instance, I'm going to do this off to the side. You don't have to jot this down if you don't want to. So if this is my A and my B, C could be straight out from A, and I could have a triangle that looks like this. Or I could have a triangle that's flip-flopped of that. So meaning maybe C wants to go to the right of A and B. Maybe C wants to go from B instead of A. So A's down here, B's here, C is here. Again, it could be the reverse of that. Or you could actually even have something that looks like this. A, B, and C. Where again, each of, I need a different color. Like this length here, that would have to be 6, or maybe this length here is 6. If that piece was on the top, it could be 6, or if it's in the middle, this could be 6. So we essentially have many different options of how this triangle could look. So the only way to go about knowing which answer choice is correct is by looking at each of them and figuring out if it could be a true or false statement. So for instance, choice 1 says the point 3, 6. So if I was to plot 3, 6, 1, 2, 3, 1, 2, 3, 4, 5. That would be here. That definitely could not be a point because you can't have 3 points of a triangle on a line. So not choice 1. All right, what about choice 2? 8, negative 3. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. That would mean, and I'm going to figure out how I can do this. That would mean my triangle would have to look something like this. Like that, and the height of our triangle, so from A to the top, is definitely not 6. If I was to count, it's 1, 2, 3, 4, 5 maybe. All right, so we're gonna undo that. Oh, I gotta hit undo a lot of times. Okay, so choice 2 did not work. All right, what about choice 3? Negative 3, 8. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. So if I was to put C there, that would mean that this would be the look of my triangle. This would be C, and if I counted back straight across, 1, 2, 3, 4, 5, 6. What do you know? So this is looking like a good option. Let's just check choice 4 just to be sure. So choice 4 says the point 6, 3. So 1, 2, 3, 4, 5, 6. If I go up 1, 2, 3, that's here. We're going to run into a very similar problem as what we did with choice 2. So I'm going to rule that one out, meaning that choice 3 was in fact our correct answer. Because if we double check here, we have a base. I know it's not in the bottom, meaning base, but like straight across with our height, because the base and the height always have to be perpendicular from one another. When you find the area of a triangle, we have 8, we have 6. 8 times 6 gives us 48, but the triangles, we cut that in half, and we end up with 24 as we wanted. So that was kind of a tricky question. It was a little bit of guessing and checking there at the end, but you can work your way through it. If you didn't understand any part of it, please call Ms. Griffin or myself over, and then I will see you in Unit 8. Over and out.